Welcome everyone to this online conference titled AI for Innovation. So my name is Dr. Alexander Hill. I'll be your host for today. So I'm Data Science Fellow at the University of Liverpool, based in the Physics Department, working within the Quasar Group. So just as a little bit background about myself. So I am a researcher, primarily working on medical physics applications, particularly in the realm of medical devices with industry. Among some of the things I do is I supervise PhD students and also provide training opportunities for them. And another part of my role is to build connections with industry and develop collaborative partnerships between ourselves in academia and hopefully yourself in industry. So before we get started with the conference today, I'll just give you like a quick outline of what we're looking at. So we have a pretty packed agenda for the day. In the morning, we have a couple of plenary lectures from Carsten, Andy, and Ben before having a panel discussion. We'll then take a lunch break, and after lunch, we'll come back for a series of breakout sessions. So these will be opportunities to speak more in depth with people working in really interesting industries who have created kind of case studies based on how they're applying AI either to their workflow or in the products that they're developing. After the breakouts, we'll come back in the later afternoon for some more plenaries, providing a kind of broader overview of the kind of UK government view of AI opportunities and AI for stimulating growth. And also we have a nice talk from Robert Cooper, who's Professor Emeritus at McMaster University in Canada, who will be able to provide a little bit of a roadmap as to how theoretically you might think about developing an AI product or function within your organization. So just a little bit of housekeeping for the day. So we're using the Zoom events platform. So this has got two aspects to it. You have the Zoom call, which a lot of people are in now. But we also have this website, which if you will follow the calendar invite, you should be able to kind of access this directly. So on this page, you'll see that you have a number of different environments. You have the lobby, sessions, itinerary, exhibitors, expo, speakers, and networking. Something you might like to do over the course of the day is to update your profile. So in the top right corner of this image, top right corner of this website, you'll have your profile. You can put in a nice photo of yourself, your job, your role, what you're interested in learning today, who you're interested in connecting with. You can also introduce yourself in the lobby chat. So this will serve as the town hall for the day. So I'd encourage you to introduce yourselves in the chat, say where you're coming from, whether you're coming from industry, academia, other public sector organizations, and what you're interested in learning today. You can also connect with other attendees using this networking tab up here. So in your profile, you can indicate that you're open to connecting with people over the course of the day. You then go to this networking tab and you can find people and engage people in one-on-one discussions. So we also have an exposition as part of this day. So you can see details here in these two tabs, exhibitors and expo. So our two exhibitors for the day are centers attached to the Liverpool Department of Physics. We have the Eupraxia and Liverpool LIV.INNO centers for doctoral training. So if you're interested in what we're doing here in Liverpool and you'd like to learn a little bit more, I'd encourage you to go to the expo and speak with Hannah Acton from Eupraxia and Naomi Smith from LIV.INNO, who's one of the co-organizers of the AI for Innovation conference we're doing here today. So that's just a kind of quick whistle-stop tour of the platform. We're now going to get started with the morning session. So we'll have 3 talks from Carsten, Andy, and Ben. And after these, we'll go into a panel discussion where you'll have the opportunity to ask any questions of the individual speakers or the panel as a whole. So if you do have any questions, I'd encourage you to, within the Zoom window, ask those questions using the Q&A button. So you should see it at the bottom bar of your Zoom window. Click on the Q&A question, enter your question there, and then we shall ask the panel these questions on your behalf. Okay, and most importantly, enjoy the day. So we have a packed agenda, hopefully with lots of opportunities to network and meet with other people. So I hope that you get a lot out of it. So I'm going to stop my sharing now and introduce our first speaker of the day. Okay, so Carsten, if you'd like to turn your... Yep. Okay, so just a little quick introduction. So Professor Carsten Welsch is a professor of physics here at the Department of Physics. He's a leading figure in accelerator science and researcher training. He's initiated and led major UK and European programs, including the SDFC Centers for Doctoral Training, LIV.INNO and LIV.INNO. His research spans advanced beam diagnostics, high gradients accelerators, and the application of accelerator technologies in healthcare and data science. So when you're ready, Carsten, please feel free to share your screen.
Yeah, thanks a lot, Alex. And good morning, everybody in Zoom land. It's a great pleasure having you here today with us for this online conference. I'm really looking forward to engage discussions throughout the day. So I'll try to set the scene a bit and explain why we are doing what we are doing and say a few words about our center, the Liverpool Center for Doctoral Training for Innovation in Data Intensive Science. Now, data is everywhere, and it is progressing at a rapid speed in all areas of society and, of course, also in research. Now, in Liverpool, we do have quite a unique track record in researcher training. We have led some of the largest training programs in the UK and indeed in Europe across a variety of different disciplines, not just physics, also engineering and life sciences. And what came out of these experiences over the last more than a decade is that really what makes training efficient is to provide cohort-based training where students are grouped by year, they work very closely together, they share their experiences, but they're working on distinct projects, collaborating where possible, but otherwise driving their own research agenda. In our Liverpool Center for Doctoral Training, we offer a structured training program, which means that all of our students follow a core training, which has data science elements embedded, which are provided by the two partner universities, University of Liverpool and Liverpool John Moores University, as well as workshops and conferences, which are complemented by contributions from our partners, from industry, from research centers, and also from clinical facilities where we are working with a number of them in the UK and abroad. We do offer quite a unique environment, and we try also to bring very unique events to Liverpool, like the event today, which we are hosting online. Another example of what we did drive just a couple of years ago was a conference for undergraduate women in physics, which brought more than 100 very talented researchers into Liverpool, and we talked about research challenges and opportunities, but also challenges that they might be facing in their careers and how we can jointly overcome these. Now, in terms of structured training, so we really believe that we can provide better training in data science specifically by giving this structure throughout the 4 years of training. This includes elements in complementary skills, project management, presentation techniques, IP management very early on in the program. We provide a data science school to our students where they are really getting a boost in their programming and data knowledge in general. We introduce them to key partners. For us, the Hartree Center on the campus of Daresbury Laboratory is one of those, and we ensure that our students visit the center in the first year of their study. And then we have many other events throughout the 4 years of PhD training. A very crucial element is that all of our students realize a 6 months placement in industry working on a project outside of their core PhD topic. That is quite a unique thing that not many centers offer. In our case, it's integrated into every single project. And what it does is it creates strong partnerships with industry. It trains students in areas that are much broader than the traditional academic area. And it also allows the academics to reach out to solve real-world solutions in addition to driving their own research agendas. We also work with partners, including charities. So in year 3 of every PhD project, our students will engage with local charities and they will work with them free of charge to tackle the data challenges that these charities are facing in an event we call Data Aid. So you can see there's a lot of training going on, and we structure all of this through career development plans that our students are setting up early on with their supervisory teams, and then they update it regularly. And this way, it's really a journey that we develop together that is very exciting and that leads our students into the careers that they would like to do after graduation. Now, this model is a success story. This photo here was taken in an online event that was hosted by the European Commission at the end of 2023, and it was streamed to more than 1,000 project coordinators and leading researchers and communicated the European success stories in postgraduate trainings. And LIV.INNO was invited to present how we are working, how we are training, and how we are working with industry in particular. And this, I guess, speaks for itself in terms of the high quality, the level of success that was reached with the center already. And of course, we want to continue this in the future. And the event today is also an invitation to all of you connected today to work with us, to propose joint programs and projects, and to collaborate with our researchers. Now, in terms of our research, I guess what drives us is questions around what enables the best research. And clearly today, data science and AI is at the very center of this. The 3 examples I have included here via the photos are detector technologies, where there are huge amounts of data presented all of the time. The Liverpool telescope, the world's largest robotic telescope, again producing huge amounts of data. And then complex accelerator-based experiments like the Awake proton-driven plasma accelerator that's shown here on the right image, where again huge amounts of data are produced and where AI helps us to make sense of this data and to optimize our experiments. We are also asking ourselves, how can we drive innovation through the use of data and increasingly AI? And that's really in the core of the event today, where we have invited fantastic speakers to tell us about their day-to-day experience, and then also later in the day to take a step back and talk about the broader perspectives that AI are now opening. And we really would then like to give you a recipe of how you can integrate this into your own workflows and increasing your productivity and also collaborating with us and our partners. And finally, the question, how can our research achieve the maximum impact? So how do we do research that produces cutting-edge science results, but also has benefit for society in more general terms? And we do that through collaborative R&D, industry placements, as I mentioned before, outreach and communication, where we engage with the general public and talk about the opportunities and also the challenges that lie in AI, and events like our Data Aid event that we organize with charities. We also engage the broader research community by organizing schools. We have organized more than 20 international schools over the last decade, including our 2024 Data Science Summer School. These schools attract typically up to 100 participants each time. We had more than 30 topical workshops on focused R&D areas, where we pick out a specific topic like data in healthcare technologies, which we will host this July. And these workshops, they are open typically for in between 30 and 120 experts and students. We also host a number of international conferences and symposia and online events, such as our seminar series and this AI for Innovation Summit. Now, key to everything we are doing are partnerships, and at the core of all of this is our long-standing collaboration between the University of Liverpool and Liverpool John Moores University. The 2 universities are in fact the only 2 UK universities that are offering a joint undergraduate physics program, and for many years now we have also worked together on delivering joint training in the area of data science through LIV.INNO now and through LIV.DUT, our previous doctoral training center just beforehand. Also embedded into LIV.INNO is our strategic partnership with Daresbury Laboratory, just a half-hour drive from Liverpool, and the Hartree Center I mentioned before. We do have very strong and long-standing links with research centers, companies large and small, and we do see those links very strategically, and we like to develop partnerships over time. We don't see it as an opportunity for a one-off project. We really like to start, show that we are serious about the partnership, engage at a small level initially and produce results, and then take it to the next level and develop it into something that in many cases can become very, very big. Now, very key to everything we are doing is Liverpool City region, and I hand over to the mayor to say a few words to us.
My name is Steve Rotherham, and I'm the Metro Mayor of the Liverpool City region. Or am I? How do you know that I'm not AI generated? Probably because AI would be more slicker, perhaps. But I'm fascinated by the possibilities of artificial intelligence as a tool to improve people's lives. And I want the Liverpool City region to be a leader in ensuring that AI makes a positive difference to people's lives. AI that's ethical, inclusive, and used for good. With the skills and the infrastructure, and of course the political will that we've built in the city region, I believe we're in the perfect place to make that happen. Next week, for instance, the world's largest IT infrastructure service provider, Kyndryl, will be opening its first UK offices here in Liverpool. Their AI hub will bring with it hundreds of new jobs, but apprenticeships and training opportunities for local residents too. At our AI Summit last November, we showcased our plans to use AI for good so that it benefits all of our communities. Look, its potential is massive. We all recognise that. Now, being one of just 3 places in the country to hold both investment zone and free port status, we have an opportunity to position ourselves at the very heart of one of the fastest growing sectors in the world. But we need your support. Our fantastic universities, businesses, innovators and entrepreneurs can really make that happen for us. Have a great day.
Now, I had the pleasure of joining Steve just last week at the opening of Kyndryl's AI Innovation Lab. And today we will actually have the pleasure of hearing directly from Ben about the fantastic lab that they have established and the vision that they have for Liverpool City region and the UK and beyond. Now, what are the opportunities for you to engage with our center beyond today? We offer a monthly seminar series where we invite speakers from all around the world. It's freely accessible and very easy to join. We have hundreds of people now on our list of registered participants, and it's by simply clicking on the link here, you can join us and join the seminars that you are the most interested in. We also have a lot of information material. If you want to find out more about the center, you can access these today via the LIV.INNO booth at the online event. So have a look at our material, including the brochure that I've highlighted here. Speak with Naomi and work with us. We are very keen to find out what your data science and AI needs are, and we can pave the way for you also to new and interesting partnerships. Finally, we also produce a newsletter, the LIV Data News quarterly newsletter. And here we talk about all things AI from our center, but also beyond. So if you have interesting news that you would like to share with others, let us know. If you want to find out about our news, then simply subscribe for the newsletter by popping your email address into the form and letting us know, and you will receive this every quarter. Now, before closing, a big thank you to the LIV.INNO team that has done the magic behind and also in front of the screen today. David and Ian here shown on the left, they are my deputy directors. Naomi, you can meet her at the stand and learn all about LIV.INNO. Then there's Sandy and Alex, who you've met already. There's Simon and many fantastic students and supervisors. And without them, our center would not be a center. So big thank you to all of them for their fantastic work and contributions. Now, for today, what we want to do is we want to discover the real-world impact of AI through hands-on sessions and insights from leading data scientists and industry pioneers. And for that, we have a fantastic lineup of speakers, and you will hear from their own experiences. And then you can ask questions about how you can possibly transfer this into your own work and research. We want to explore the emerging frontier of physical AI and uncover where you can seize the next big opportunities for growth and innovation for yourself, but also for your business. And finally, we want to put you in a position where you can build your own personalized AI action plan, benefiting from what the UK government has done, and do that in an interactive and hopefully also fun environment. So as Alex said, most importantly is enjoy the day, and thanks for joining.
Thank you very much, Carsten, for that lovely welcome. So now we'll move over to Andy Walker. So just make sure Andy's here. Yep. Great. So I'll just do a little quick introduction for Andy. So Andy is head of commercial for Deep Tech at the Technology Partnership, or TTP, a product development consultancy consisting of 350 deep technical experts in science and engineering based near Cambridge. So AI plays a major role in many of the client projects that TTP engage in. Prior to TTP, Andy led the commercial strategy and execution for 10 years at McLaren Applied, leading strategic relationships, exploiting technologies such as data analytics, digital twins, and safety critical electronics. So Andy today will be talking to us about who will steer the future of innovation, humans or AI. So when you're ready, please feel free to share your screen and get started, Andy.
Right, thanks, Alex. Right, let me do that.
Yep, looks good.
Okay, so everybody can see that. Well, thanks for the invitation. Thanks, Professor, for the opening address there, and good to hear from the mayor. So I think it's a slightly provocative title here: who will steer the future of innovation, humans or AI? And this is not just about innovation. This is about the relationship between AI and many human skills, I think. So I think it pays to ask the question and consider the potential factors that might influence it. And as people involved in innovation, AI is developing faster than ever before. And therefore, it's critical that we understand this, both in terms of the future potential, but also the future pitfalls of the technology. And that's what I'm going to take you through today. So if we look at what I'm proposing from an agenda, given that I'm first on, then I think it's probably up to me to just perhaps frame our AI journey from a technology perspective, in terms of what's happened in the past and where are we now. And then I'm going to talk about how that impacts innovation. And I'm going to do that generally to start with, just as a sort of brief, broader view, but then I'll dive into how I think it specifically can help in innovation in physical AI and things that interact with the real world, which I think is a really interesting area. Given our role in product development in TTP, I'm then going to talk about the role of AI in product development in particular. And I'm going to give an example of where we're using modern AI and exploring how that can be used to really save a lot of time and improve the quality of product development. And then I'll leave you with some thoughts about some things that you might want to consider doing yourselves when you get back to the office tomorrow. Okay, so this is not a sales pitch at all, but I just thought it'd be worth a single slide just to explain the angle and the context that I'm coming from. So as Alex said, our core business is product development consultancy. And what we do every day is help our clients break new ground with new technology. So we really do innovate every day. That's our kind of reason to be. And so when we think about the value of AI, we're thinking about it both in the context of the process of product development and the tools that we use to help us do that, but also how AI can figure within the products that we actually build and deliver as well, and how can we take best advantage of the new technology for that. And so we do this across multiple markets. So we've already heard some of those mentioned today, but we're active in health, life sciences, and then what we call deep tech, which includes satellite communications, green technology, so sustainable technologies, hydrogen economy, those kind of things, and defense and aerospace. Okay, so enough of who we are. Let's start the journey then. So from an AI perspective, I like to think of it as a sequence of phases, but actually, whilst they are sequential, they're also parallel, and I'll explain a little bit about what I mean by that in a second. So if we first of all think about, the first steps in AI were really what we would call symbolic AI. So here, the intelligence is defined by rules. It has to be coded ahead of time to know what the rules are, which needs lots of expert knowledge, needs lots of algorithms, and some good examples here in terms of databases, search, expert systems, and so on. And it started in the 50s, golden age in the 60s and 70s probably, but still figures in certain problems today. But most famously, perhaps in the late 90s, Gary Kasparov lost to Deep Blue, the IBM AI computer. And he famously said it wasn't a big day for chess and it wasn't a big day for AI. But I guess, you know, it kind of was to a degree, because it was the start of the journey. So beyond that, of course, we moved into using what we would call classical machine learning. So here, actually, rather than rules-based, we're actually creating specific intelligence through learning, but it needs lots of data and lots of algorithms. So examples here might be image and speech recognition. But of course, using this technique, you do need a lot of data of certain images in order to be able to then recognize objects in other images. And this started as way back in the 90s. In fact, I was using this for speech recognition back in the 90s. And we had lots and lots of training data and, you know, some early forays into AI there. But it really, the golden age probably was in the 2000s and the 2010s. But again, it's not something that's finished and has been overtaken. It's something that's still valid for certain types of problem. So if we think back up to the sort of modern day, where are we? Well, actually, then we're talking about these new foundation models where actually more general intelligence starts to emerge from a critical mass of information. So a large language model with a bit of expert knowledge, with a bit of data and some algorithms can actually solve many problems, and some of them a little bit unexpected that they've not been specifically trained for. So obviously we all know about Gen AI and autonomous agents on the way, but is this a route to AGI, automated general intelligence? Who knows, but we'll keep an eye on it. So what have we achieved so far? So this graph on the left is a little bit out of date now, but it shows the trajectory of the performance of AI in a certain number of tasks that it's useful to use AI for. And I guess the way I tend to think about this is, let's think about the steps of AI as it improves, in terms of thinking, is it as good as a GCSE student? Is it as good as an A-level student? Is it as good as a grad, a PhD, and so on? And certainly given the trajectory that we've seen here, the move in foundation models and so on, then lots of big businesses are really excited about this, as you can see from the quotes here. And in fact, we've seen some massive investment commitments as well. So $1 billion from Accenture over 5 years, $1 billion from Oracle. All these major corporations are really investing in this area. But of course, it wouldn't be new technology without entering the old trough of disillusionment, which I think generative AI is now in. But I think that's actually quite healthy, because what that does is it raises the bar in terms of how useful things need to be for people to invest in them and make them happen. So I think in summary, the jury may still be out in terms of the true final outcome in impact, but I don't think anybody can deny that we can't ignore it in innovation, and we need to crack on and understand how we can use it. So next, I'm just going to talk about specifically innovation more generally in terms of what impact AI might have. So we can think about this really, I tend to think of it as a bit of a spectrum. So on the left-hand side, we've got AI, you know, one scenario is that AI ultimately innovates on its own. And it's got lots of skills. It's very good at all these things here, processing data, automating tasks, and so on. It's quite good at creation, at least from its training set. But it does currently hallucinate, which can be a bit of a problem, especially in safety critical situations. But it's interesting, isn't it, that when we think about human beings, actually, we always say there's a fine line between genius and madness. And maybe this is what we're seeing here with AI. And who knows whether the current generation of AI will lead to AGI or not. But I think, in my view, that's going to be too automated. So another scenario is that, you know, humans continue to innovate on their own, and they have some good skills there, but actually a finite effort and stamina, and are limited in speed. So I suspect a lot of us believe that AI and humans together are going to be the answer in terms of how what impact AI is going to have on innovation. And I think augmentation is a word you'll hear quite a lot today. I think that's what we're looking at in innovation here. But actually, there is some caution needed as well. So, you know, will it have an impact on our critical thinking skills? Will it have an impact on the value of the human spark? These are all open questions we don't yet know the answer to. So to sort of try and help us think about that, I just thought about some past examples where we may have been worried about some innovations that were coming. So first of all, the humble calculator. I think people were worried our brains would turn to mush once these were in the hands of people, particularly mathematicians. But actually now I think we all see this as a positive tool that allows us to invest time in more complex things with no real negative consequences. The next one to think about is sat-nav. Have we all lost the ability to navigate as a result of these? Well, probably some of us have, but equally we've also gained as a result the ability to not just use it when we go to somewhere we don't know, but use it on our regular journey to work, perhaps to check what the traffic is and to get more value out of it that way. So the open question is, when we start to use AI more and more in innovation, is that going to affect some of the skills that we've got today or not? And interestingly, Microsoft are clearly concerned about this. They did a research paper earlier this year where they found that there's a range of attitudes to using Gen AI in innovation. And what they found was that the people who had higher self-confidence in their own abilities basically led to them continuing to do more critical thinking, whereas those that shifted their confidence into generative AI led to less critical thinking from them. And that started to distill down to kind of things like information verification, response integration, and task stewardship, which is actually probably not the main things that you would associate with a good innovative brain today. So definitely some caution required there generally, but definitely potential as well. So if we start to think specifically about physical AI and the real world, so what do I mean by physical AI? Well, this is a graph that if you saw Jensen's talk from NVIDIA at the beginning of the year, you'll recognize this, and the journey from perception AI to generative AI to agentic AI, so more automation there, to physical AI. And we're talking about things like self-driving cars, general robotics, things that interact with the physical world. And I can't really sort of talk about this without thinking a little bit about a quote that I heard from Nigel Toon. Some of you may have come across his book. I was lucky enough to see him speak a few months ago, and he described, you can read the quote here, but this year 150 million new intelligent machines will be delivered. Each one has the potential to be more intelligent than you, and during your lifetime they will end up setting laws, will advise and even lead governments. These new thinking machines will be running our businesses and also start many new ones. They'll beat our current sporting champions in every event. And in your old age, you need to hope that these new intelligent machines will look after you, because in time they will control everything. They end up in charge. We call these intelligent machines children. So maybe things aren't so bad after all. But some learnings there, because I think actually the way that children learn is perhaps a bit of a clue as to how we need to continue with teaching AI as well. So if we think about physical AI, what about the advances and the dangers? So Gemini Robotics, part of Google DeepMind, have done a lot of work on some pretty advanced models recently. And this is now getting to the point where robots can react to non-trained situations. They can react to changing surroundings and actually do relatively complex tasks for a robot in terms of knowing that a two-finger grasp is the way to pick up a coffee mug. So you can't really think about all those advances without starting to think about the danger. And lots of people are concerned about this. I think when I think about it philosophically, I think about the books I read in my childhood, the Isaac Asimov books, where he did a really interesting job for his time in terms of thinking about the kinds of rules that we might need to encode to protect ourselves in an age of robots. But actually through reading his books, and those of you that have seen the film will realize that even though these look like a pretty solid set of rules, there's still going to be exceptions and difficulties around these. And actually that's quite apart from the really complex task of actually encoding these and making a robot adhere to them. So more short term, what can we do about this? Well, some of you will be familiar with the concept of a software bill of materials. So this is the idea of saying, actually, you need to be really clear about the provenance of any open source code, versions of code that you're using within that software so that it's traceable and you can be a bit more confident about its success. People are now beginning to extend that to AI. And I think as we go from a situation where perhaps traditional software is maybe 80-20 code to data, to AI being probably 80% data and 20% code, then obviously the provenance of data and the models becomes really important, especially in the light of new waves of potential cyber attacks that can do data poisoning of training sets and all of those kind of things. So I think there's something in that concept that we probably need to take notice of. Okay, so if you think about AI in product development, what does a typical set of steps look like in product development as a whole? So we tend to follow a model a little bit like this. So the first half is more about concepts, so generating them, evaluating them, and then selecting them. And then once we've got the leading concept or concepts, we then do the generally more expensive things of turning it into a prototype, testing it, and deploying it. And a couple of examples of things that we've looked at here is, well, what about, there's always a bit of an overhead at the beginning in terms of doing the sketches and the CAD that's needed to actually get to a concept you can articulate and share with others. So we've done some work to look at how generative AI can be used to go from a rough sketch to a 3D model or something in CAD that's then easier to handle later on. And we've had some success in doing that. But then what I'm going to talk a little bit more about today is actually the use of engineering models to test and compare concepts in the virtual world. Now, a really good example of this, where this happens already, is in Formula One. So you may know that they have limited time to test new innovations on track. They're continually innovating. I mean, the rate of innovation is amazing. Basically, if you had the car that was the fastest at the beginning of the season and you did nothing to it, you would be last on the grid by the end of the season. So they really do innovate at a huge rate. And a large part of that is dependent on a very complex engineering model that they've put into a driver-in-the-loop simulator that allows them to test new parts before they commit to develop them. But I think when we think about the kind of product development we do, which is more at the device level, medical devices, life science lab tools, SATCOMs devices, and so on, then we often use engineering models in those to avoid the expense of a prototype. But actually today, that's quite an expert job. So we have a team of experts that are capable of doing that, but it takes their time to do it. And just sometimes it can be cheaper to kick out a cheap prototype, a simple prototype, than it can be to actually do the complexity of the modeling. So we need to shift that balance if we can. We think AI has the potential to do that. So let me talk about that as an example then. So if we think about engineering models and digital twins, we can plot a bit of a graph of how useful they are versus how much they cost. And at the top right, we've got what I would call a true digital twin. So, if you're building a retail warehouse, you want to know where all the conveyor belts are going to go, how fast they need to run, where the supplies are going to come in, and so on. So you might spend several £1 million on a pretty complex digital twin, but that can be quite expensive. Well, that is expensive to build, and it could also be quite expensive to maintain if things change, and can lack a bit of granularity for those decisions at lower levels. So at TTP, we use a lot of what we call engineering models. So these might be built in a variety of ways for a specific part of a product or a process, and these can be really, really accurate, but very specific. But they actually today require an expert in modeling, in the modeling tool, and particularly the product we're trying to build, to actually build the model. So still quite expensive. So what we're looking at is the potential of what we call a seed digital twin. So this is where we get AI to help us generate the digital twin. It's quite accurate, it's very cheap. It could be used at design time in the development process, as I've talked, but ultimately it could be a digital twin that's used at runtime to help control a process, for example. And today, this does require a bit of an expert in AI. And you need to have some knowledge of the problem in hand, but we can see this progression we show here of these things becoming much more capable and much cheaper to build as the tooling improves. So we're kind of taking ourselves along that journey. So what do I mean by that? Well, if we think about digital twins and engineering models, it is an expert process. And typically you go from having to understand reality to build that into a conceptual model. And then you then make a final step of building that into a model that is implemented in code. Now, we already know that large language models are pretty good at code generation. So that right-hand step is already sort of reasonably well understood. But what we're working on is the left-hand step of saying, well, actually, instead of an expert having to sit down and write that model from scratch, perhaps an LLM can do a lot of the legwork, and then the expert really just have to check what it's done and to iterate with it to make sure we're on the right track. So that enables you to build what I would call a theoretical model. So you're building it from the equations and formulas that are well understood in that particular domain. But what you might want to do is think about how can you make that into a more empirical model that takes into account data that you might have collected. So here you would use the LLM to do the conceptual model, produce the code for the model, but then you could introduce a small quantity of observed data, which will allow you to evaluate that model and calculate a loss function so that it can be adjusted for working in the real world. So this, I think, has a lot of potential, actually, because traditionally a challenge with building a model from machine learning has been the quantity of data that you've needed. But we think there's a lot of potential in these hybrid models that effectively have a theoretical base and then only need a smaller amount of data to then make them a bit more empirical and a bit more reflective of the real world. So we're quite excited about that and working on that in a number of different domains. And so finally, I just wanted to talk about 3 things that you might go away from here and do tomorrow, but I'm sure we'll develop this throughout the day as we have different presentations and more discussions. So the first is, I think everybody needs to stay pretty close to the developments in AI because it's an ever-changing picture. So a constraint today can be an opportunity tomorrow. So piggyback on the work that other people are doing wherever possible, and don't leap into developing something yourself because you think it's not out there in the market, because the chances are that in a few weeks or months' time, it could well be. Don't underestimate the power of current tools as well. So we all know that AI can create code, but actually it can also run it and evaluate the results too if you know how to prompt it. So there's certainly a lot of skills to be learned there from a prompt engineering perspective to get the best out of generative AI and the tools that are based on it. And then finally, whatever happens, retain the power of critical and creative thinking in your innovation function. Because if we get totally reliant on AI, we're going to miss the human creative spark and the critical thinking that's so essential to make the breakthrough leaps that we've made through history. Okay, thank you very much. So I don't know whether you want Q&A now, Alex, or whether we're going to do that in the panel, but I'm happy to do that either way.
Yeah, so what I'd do is I'd advise attendees if you've got any questions to put them in the chat, preferably in the Zoom, but you can also do it in the lobby on the event's webpage, and then we'll address the questions during the panel discussion after the next talk.
Okay. Excellent. All right, I shall stop sharing.
Wonderful. Well, thanks very much, Andy, for that overview of AI and how TTP is approaching AI innovation. So next, we're going to move on to Ben Scowen. So Ben is an IT executive with over 27 years of cross-sector experience, leading digital and cloud transformations that drive business value, efficiency, and innovation. So excitingly, Ben is leading the new AI Innovation Lab in Liverpool for Kyndryl, which was announced as part of the UK government's AI Opportunities Action Plan. So Kyndryl itself is one of the biggest global IT infrastructure service companies that designs, builds, manages, and modernizes mission-critical systems for business and organizations. So Ben, when you're ready, please share your screen and get started.
Well, brilliant, Alex. Just a sound check. I think you can actually hear me. I would just want to say a very quick, massive thank you to Professor Carsten for inviting me to here today. A real pleasure of mine, and a very interesting talk there from Andy. So my background for everyone is originally a software engineer, so I've programmed a lot of software back in the 90s and the early 2000s, and then moved to being an architect. Climbed up the ranks in an IT company and ran a few businesses in there. But at my heart, I'm still an engineer, and it gives me great pleasure to do a session like this. So what I want to do is give you 2 aspects to this talk. First of all, I'll give you a bit about why Kyndryl are doing what they're doing in terms of Liverpool and the Innovation Lab, and then I'd like to take you on to a bit of thought leadership I did last week at the AWS Summit in London, which really looks at how to, I mean, it's interesting hearing Andy talk, right? Andy was talking about all the possibilities, and I really, there was loads of things I'd love to spin off and talk about. Maybe we'll talk about in the panel session. The other angle is, how do you embrace this? How do organizations take AI and make it into something useful? How do they control it in a way that it's not going to disrupt their business and then potentially expose them to risk and even worse to liabilities that could affect their business significantly. So I'm going to do a bit of a talk on that. So let's just start with the Kyndryl piece. So, you know, Kyndryl was a spin-off from a company called IBM. IBM, obviously a massive company and around for many, many years. We were the infrastructure component of that. In other words, we delivered all the data centers and the computer services, underpinned all of the applications, right? That was our background. We spun off about 3 years ago. And the adventure, as I call it, as Kyndryl, is all about taking and modernizing and becoming and not only leading the digital and AI space, not just in the UK and Ireland, but also globally. I represent the UK and Ireland. We're a global company. We're an American-based company headquartered in New York. So for that infrastructure business, we've got lots of data centers, but we didn't have lots of delivery centers. Now, my team are on the cloud practice. We've got a team that's distributed around the UK and Ireland, but we didn't really have a central, delivery spot. So we looked around the Northwest, and let's be honest, Manchester was saturated. There's lots of companies there already. Liverpool had amazing universities, both yourself, Liverpool University, and you've got John Moores as well. So lots of talent in the local area. That was really critical to us. And I think what the mayor has done and Liverpool have done with the AI Summit last year, and also this infrastructure, the networking infrastructure we've got in Liverpool, the building architecture, the actual place, it's an amazing place to bring customers. So that's why we ended up essentially building it out in the Live building, because it was in a lot of kudos. It's a great place to do it with lots of talent around it. The other aspect of this thing that's really important is, and Andy talked about it a lot, is this is a revolution. I forgive me for this, but I genuinely thought it was a bit of hype. I was at the point where maybe this is, it's just a little bit out of control. You look at the hype cycle and all of that. But I've been doing a lot of interviewing of our engineering teams and our professional side of consultants, and as well as personal friends and all this. And I've been interviewing and what they're using AI for. And the reality is everybody's using it. Everybody's using it in a different way, both in business and their personal lives. This is not hype. This is real, and it's going to be profoundly different, change our lives. If you look at back, when computers came into our offices in the 80s and our homes, actually, I got my first computer in 1982, ZX Spectrum 48K, if anybody remembers those. Then we had the advent of the internet. Then we had mobile phones. Then you can argue the cloud and the virtualization of infrastructure was the next sort of revolution. And now AI. Really, in that last sort of 40 years, we've seen some huge changes, and I think AI is probably going to be one of the biggest ones of those things. So that's really important that Kyndryl have a delivery center that focuses on AI and how customers can take advantage of it. It's not that straightforward in how AI actually is going to affect our business and the IT industry, but it is going to affect it, and it's going to affect it profoundly, and it will change the way that our jobs are done, and it will change the things that you study. My son's at university doing software engineering. One of the things I say to him is, obviously do your curriculum, but you need to be learning about everything. It's moving so fast. There's no curriculum that can keep up with this. It has to be a constant learning and a constant point of learning. And the final point I want to make, just Andy mentioned it, I think the effect on critical thinking could also be profound. And I do agree with that statement that you've got to keep ahead of it, or else it will become the sat nav for us, right? And we don't want it all be reduced to the point where we don't think for ourselves. We only rely on the AI output, because the AI output is not always correct, right? And we have to be discerning in doing that. So really, that was the reason why we're here, and I'm very excited about setting up the Innovation Lab in Liverpool. This will all be about helping customers and clients and academia take advantage of AI, make it into something useful for them, and doing it in a controlled way. So what I want to do now is, and I'll just share my desktop, I'll give you a bit of a thought leadership piece on and I have to work the technology. I use Teams all the time, so where's my shared desktop? I was trained there. Oh, there it's in the middle in green. Right. So if I just share my desktop, you hopefully can see my screen now. So can you see that there?
Yep, looks good.
Yeah, good. Right. Okay. So let's just take a step back, right? And if you think about when you're trying to run a business, any business, small or large, doing that with technology can actually be quite difficult, right? Now, I know there's lots of reasons why it makes it easier in some respects, but it's actually generally quite difficult. And that's because the tech is moving so quickly. We've discussed that. It becomes obsolete very quickly. There's an awful lot of it, and the combination of it are pretty much infinite. If you look at an AI stack, holy moly, that's changing all the time, right? So understanding what components of an AI stack you want to use for, whether it's for generative AI or agentic AI, is quite difficult, right? Now, the brilliant thing about that is it's never made it so easy to innovate. And so this is for the people in this, you guys on the call, girls on the call, this is the most exciting time. You're going to be able to do so many amazing things so quickly. At the same time, though, we create a lot of technical debt. And what I mean by technical debt, that is you build something, it works, but it then no longer maintained, or it requires resources to maintain it. And maintaining technical debt takes up lots of our time and money. And what I'll talk about now very quickly is the relationship between resources, technical debt, and innovation is what I call the innovation doom loop. And really, you need to take an AI-driven product and platform engineering approach if you're going to address this. And that's the only way you're going to break it, in my humble opinion. And actually, there's an add-on to that. You can actually avoid AI becoming the next example of massive technical debt because it democratizes, AI democratizes doing stuff. In other words, not very good engineers can become much better engineers very quickly, which is a good thing, by the way, because of AI. So it means everyone can build code. It means everyone can do stuff, which means we can build an awful lot of services and things that will become critical to our business that we need to run. So the question is, how do we do that? And that's really what this talk's very quickly about. So the innovation doom loop, it's basically, think about this, it's an important concept, right? Resources, so that's your people, your money, and your time, right? And they can spend their effort on maybe two things, right? Innovation, i.e. building new services, and enhancing the services you've got so you can essentially grow your business, yeah? Or you can spend it on the things you've already built that are functioning, but they're no longer they may be essential to your business, but they're no longer the critical focus, right? And as time goes by in a business, if you model a startup, right, when you take that startup over a period of 10 years, to begin with, you're spending all your time on innovation. By about year 6, it plateaus. By year 7, you're starting to see a distribution of 50% of your effort on innovation, 50% on technical debt. And by 10 years, you're talking 75% of your resources spent on technical debt. What does AI do to this graph? I don't actually know, right? There's possibilities here. AI could even make it so we can build so much new stuff, but we can also, to Andy's point, we can use it then to optimize the things we've built. So in other words, we use it to create and optimize, and that's, I suggest, is the way it's going to have to be. But where this graph goes, we need to try and get the grey line down and the red line up, because that's what makes companies thrive, that's what makes them successful, and that's what we're trying to do. So that's the innovation doom loop. Now, this is pretty heavy, right, what I'll go into now, but you'll be all in different parts of your education and your life experience in terms of what you're working. But product and platform engineering is a really, really important concept to get your head around, right? So the way organizations are built today is they will set themselves into lines of business. So you imagine a bank, right? There'll be an insurance division, there'll be a mortgage division, there'll be a pensions division, right? They'll be split up into different things. That's our product. That's the thing they're going to sell to you, me, as part of the, our digital experience with the bank. Yeah. Underlying that, if we let those product teams just build the way they want, then they will have the effect of building multiple platforms that could actually be reused across lines of product. So the concept of product and platform engineering simply says you need to think about your platform and share it amongst your product teams. And that way, you're going to have a massive amount of success. You're going to be able to scale your delivery. You're going to be able to innovate while avoiding technical debt, align this business society, optimize costs, all the benefits you can see on the screen. Now, there's 16 things that you have to do to bring this together, right? And I'm not, again, we could do a further session in this. This is just to sort of get a bit of a taster. But these 16 things, you might have heard of these things, but they all work together. And what often companies do and teams do is they don't put them together. So for example, DevSecOps, which is the concept of building and running services. So I build the house, I live in the house, and I'll build security in from the very beginning. I'll automate everything. Is very closely related to site reliability engineering, which is once I've built that thing, I'm going to maniacally optimize it, right? So DevSecOps and SRE fit together. So do Agile delivery, so does FinOps. And then if you look at the left-hand side with minimal viable product organizations, you guys will be hopefully getting into things like platform engineering and cloud native development. And these concepts all fit together, right? And this is what product and platform engineering is all about. It's all about bringing these things together. And of course, the new kids on the block, I mean, Andy discussed that machine learning has been around for a long time, but as you know, the advent of LLMs and actually reasoning engines with agentic AI, I mean, that's what blows my mind is the reasoning engines and how they're overlaying on top of the LLMs is profoundly changing the way we build services and push them out to market. So what I'll do is very quickly take you through how AI is affecting that. Now, I haven't got time to take you through this today, but every business needs about 40 platforms, and through those 40 platforms, they'll build out customer experience and digital products and services. And you can organize yourself in a number of ways. Now, for engineers, organizing yourself seems like, why would I care about organizing myself? Well, the reality is, if we have an army and it's just a bunch of random warriors, that's great, right? But organized armies are very successful because they've got structure, they've got autonomy, they've got rules of engagement. And that's what we need in an IT business. We need to have our platform teams separated from our digital teams, but joined up. Loose coupling, high cohesion, right? Standard software engineering principle. You need to apply the same principle to organizations. So I haven't got time, but most of the second model is what most people do, just hire some cool people, build some stuff, but that's where most of the technical debt gets created. You need to move into a right-hand model where you actually, you bring together DevOps and SRE, you put this in together and you're more organized. Again, this requires probably an hour on its own to take you through the concepts here, but very important for businesses. Now, what's the dividend? So if you start to model doing this versus a traditional approach. So in the graph and the traditional approach, actually it's less build effort to begin with. Click ops, as we call it, just clicking the mouse, clicking around, building stuff, brilliant. You'll go really fast, right? And you'll produce something very quickly. Building with a product and platform engineering requires more effort, right? And I'm going to go into how AI affects this in a minute. But what you get very quickly with a product and platform, when you automate everything and you codify everything from the very beginning, you get change agility. And you get operational efficiency. You get the ability to build stuff, change it, and optimize it using SRE techniques very quickly. And the key difference between the two models is you can oscillate technical debt, which means you can constantly batter it and reduce it and make sure that it gets reduced to a lower level. Whereas in a traditional approach, it's out of control. Nobody knows how it works. It wasn't documented. Maybe we can use AI to deconstruct it, reverse engineer it. But either which way, you've got a liability in your hand. And that's why product and platform engineering is very successful. Now, if we start thinking about how AI affects this, it's profound, right? So if you take three main stratas, right? Let's take agile delivery and testing, yeah, which is kind of the bit that least software engineering in some ways. It's profoundly affected by AI. Generation of use cases, user stories, acceptance criteria, gap analysis, risk assessments, all the stuff that used to be really manual. All my testers, all project managers, they're using AI now to vastly accelerate what they're trying to do. Software engineering, I won't bore you with this because this is obvious. Code generation, agentic coaching, bug fixing. How much is my code going to cost me if I run this in the cloud? That's incredible, right? And then operations, doing that performance analysis, getting the data and analyzing it to work out how I can optimize the things I've built. You can literally save millions for companies to do this. Vulnerability scanning, compliance with regulatory standards. AI is going to profoundly affect that. But on the other hand, and Andy touched on this, there's a yin and a yang, right? This is shadow IT on steroids. Everybody can build stuff now. It's democratized it. It's going to be a tidal wave of cost, risk, and environmental impact. If you do bad prompt engineering, you might take 30 prompts to get your answer out in LLM. If you get trained, you might take 3. How much energy did that cost? How much money did it cost your business? If you don't have a centralized AI platform, if you don't centralize it within your organization and embrace that in an organized way, you're going to cost your company a lot of money and expose it to risk. Data sovereignty is a massive problem now with the geopolitical situation. Europeans certainly are looking at how they invest locally in the company and country to build out services. You know, as my customers talking to me, it's a fair thing. It's nothing wrong with that, right? But what we've got is enthusiastic data leakage, as I call it. And what I mean by that is people, yeah, I've uploaded this spreadsheet with all our data in it to ChatGPT, and I've done this analysis, and it's fantastic. Look what I've done. It's like, you realize what you just did? So we've got to curtail some of this enthusiasm. I'm dead enthusiastic, so I don't want to curtail enthusiasm. That's the wrong way of putting it. We need it to be more channeled and it to be done in the right way. So, and then there's bringing the AI to the data. It's going to be a big theme that we're going to see going forward. And we need to use AI to affect it. AI can help us reduce technical debt, but it can also help us increase it. So we need to think about that relationship. Okay, so finally, what I say to customers and clients and people who want to do this, I say, if you want to start this, own it, learn all those concepts I've talked about. Don't outsource that to other people. Find yourself an exemplar, build a real case and get it to production using a number of the techniques. Don't use all 16. You say start with 10, start doing that, and then scale that out across your organization. And lastly, ensure what you've built is still running and successful using DevOps and SRE. So that was really, I've hopefully met the time target, Alex. But that was really what I wanted to present there. I think it's an exciting time in terms of where we're at, both in Liverpool and in AI. I think that Kyndryl can help with that, but on a personal level, I want to help with that as well. You know, I fundamentally believe that the UK and Ireland need to build up really strong technical capability and lots of businesses that can thrive in our own country to deliver these kind of results for our own citizens. It shouldn't be outsourced. You know, it should be internalized as in the country, because it will actually provide jobs for everybody and actually link and interesting, I think, is probably the last bit of that. So Alex, if that's okay with you, I'm finished. But that hopefully was interesting, and you know, obviously people can contact me directly if they want to ask any questions.
Wonderful, really fantastic talk, Ben. Thanks very much. So at this point, I'd like to welcome back Carsten and Andy, and we'll get started with our panel discussion. So as we've already said, if you've got any questions, please drop them in the Q&A or the lobby chat. I can take a little look at that as well. Equally, attendees should be able to raise their hand. So if on Zoom you'd like to ask a question in person, you can introduce yourself, say where you're coming from, raise your hand, and then we can kind of call on you to ask your questions. So we'll just kind of start off with a quick one for Andy that's going to come in. So you've talked about kind of basing kind of development cycles, kind of rapid innovation on the F1 model, where you have these sort of mission critical systems and you're trying to kind of tinker with some aspect of it whilst not kind of radically affecting something else. And you have these kind of quick cycles, but you're always trying to balance risk and reward. However, if you're in F1, your equation for risk and reward might be changing quite a lot. You know, if you're trying to maintain a winning position, or if you need to have like an insurgent kind of rush through, kind of late half of the season to kind of catch up in the Constructors' Championship or something. So I wondered, like, how do you kind of go about kind of balancing the risk and reward in that kind of sort of shifting context, and whether you would approach the work that you do with businesses with the same kind of mind? Like, you know, would you say, oh, you have like a great need for innovation, so therefore try these higher risk, high reward strategies, or, you know, is the opposite true?
Okay, gosh, that is an enormous question, isn't it?
Yeah, sorry.
So many different types of risk and reward and so on. So I think, yeah, the best way to answer that, I guess, is that at the end of the day, you know, if we just go back to Formula One, it's quite a nice environment because there's a very simple currency, which is lap time. And at the end of the day, actually, there's an interesting thing here actually about, you know, surely you could just have an AI drive the car and work out what was the theoretically, you know, best engineering solution to the car. But of course, you can't do that because you've got to introduce the human driver into the loop. And actually, the most important facet of that driving the loop simulator is the hardware that generates the vibrations in the seat of the car that the driver sat in, so that the sort of simulated environment accurately replicates what he feels when he's on the edge of flying off the track on a corner. And that's kind of an interesting sort of thing there. But I think, you know, that is a very different environment to a regulatory environment where, you know, you might be trying to create, you know, a medical device and adhere to the rules there and so on. And certainly, I think the appetite of regulators is moving really, really quickly with respect to AI. You know, it's happening in health. We're seeing it in aviation with drones and beyond visual line of sight operation and all of those things. And, you know, who knows where all those things will head and how quickly that will move. And I think I saw some stat the other day that the FDA have got, I think they've approved something like 900 AI devices, I think now, or classified as AI, but then it creates a whole, you know, and then somebody was saying that actually at the moment the rules allow you to, if it's an AI device rather than a traditional device, then you're allowed to change the data without getting it reapproved. But actually that's fundamentally quite risky, because we all know if you change the data within the AI and what it's trained to do, then you could get fundamentally different results. So there's quite a lot of complexity there. So I think we are trying to experiment to innovate, but doing that in the context of the regulatory and the safety aspects of the businesses that we're working with. And I think you just got to keep an eye on that, really. And you've got to work out what your kind of appetite for corporate risk is and whether you're really taking a risk. And then secondly, you know, really have a sit down with the client to understand what their appetite is as well. Because it's not just, you know, every client in a particular market will be completely different as well. So I think you've got to enable a dialogue. And I think the key thing is consciously taking risk, not unconsciously taking it. I think that's probably the key point.
Sure, that's really interesting. And just to follow up on that, so I mean, as we've kind of heard in all these talks so far, AI is developing incredibly quickly in all kinds of domains, and regulators are playing catch up, I'd imagine, in a lot of situations. So when you're working with a business, are you not necessarily looking at what the rules are now, but what they might be 5, you know, even like, you know, 1 or 2 years down the line? Does that come into your kind of proposal in any way?
Absolutely, yeah. And I think so. There's 2 aspects to that. So one is sort of having a bit of a future look as to where that might happen and where that means the opportunities might lie. So a good example actually is where at the moment you can't fly beyond visual line of sight without special approval and so on as a UAV operator. But actually, if you have something called detect and avoid and resilient communications, then actually it might lead to a situation where you are able to do that. So, but it costs a huge amount of money to develop a detect and avoid system. Therefore, the judgment call is, well, actually, will the regulator get to the point where they will allow things with that, and how much is that worth, and so on. So I think that's one aspect of it. And I had a second one, but has now slipped from my mind. So I'll stick with just the first one.
Maybe I can just follow up there, and because I had a question for Ben, who made a number of fantastic statements in his part of the session. Alex, as you just said, this is one of the most dynamic times, and Ben, you said it was never so easy to innovate. If I can quote you there. So when you look at the graduates that you are recruiting now, that you see joining companies, what key skills are they missing in order to be effective in that very dynamic environment? What trainings are universities at the moment not providing?
It's a good question. I maybe I'll skirt it slightly, but I don't think it's a lack of the skill. I think, look, fundamentally, if I'm hiring a software engineer, I don't really care if they're programmed in Python, Java, or, well, maybe I do, maybe scripting versus object-oriented or JavaScript, but I want them to demonstrate to me they understand the principles of software engineering. Yeah, that's the key. Yeah, so it's the concepts that are more important than the actual language. So and I think with AI, what's proving to be a good example is a project. I was interviewing one of our engineering teams, and I asked them how they're using AI, and they turned around to me and they were telling me all these things they were using it for. And the lady said to me just before they call in, she said, "But the best thing is that I was a project manager 2 years ago. I'm now a platform engineer," because she's been using AI to teach her very rapidly, because it's very, I mean, everyone's using it, so you know it really does give you a very it's very teacher-like the way it responds to your requests. It really takes you through a very quick learning curve. So I'm not worried about people leaving university without the specific language skills, because I think they'll change, and they change really quickly. And maybe Python 1. I can't believe Python 1, by the way, because it's been back since 2000, and it's like it wasn't the big then, and Java was the king, and now Python's the king. So I think that's not so important. What's very important is that people understand the concepts of how foundational models are created, transformer patterns, all the and reasoning engines, and make sure that they understand the techniques and the concepts that are happening in the AI space. Because I think, and to Andy's point earlier in his talk about learning how to do prompt engineering, so maybe these are the skills that I think will be at the moment. It must be a nightmare for you guys having to react to this world, right? It's moving. I mean, it didn't used to move this quick, right? It moves really fast. So the short version to your question is, I think the concepts of AI and less of the specifics is more important, because that then equips students and engineers with the ability to adapt to the inevitable change that's going to happen.
Yeah, I mean, we certainly have to deal with the effect that you described earlier when a staff member uploads an Excel file into ChatGPT and shares that data. And in research, it's the same. I mean, people are uploading data without realizing that they are putting under risk a patent application or their next paper, because they are making it openly available to everyone. Now, just picking up on what you just said and what you said earlier, you did suggest to your son, I believe, that he should gain a number of diverse experiences also outside of the core university curriculum. So would you say that really valuable skills come from that exposure to different sectors, different environments, gaining practical hands-on experience in addition to the theoretical framework?
Exactly. I think that you've got to set up your own projects. There's an amazing book called The Beautiful Question, and it posits the concept that it's not the answer, it's the question you ask yourself, right? And I think what we need to develop and as humans is, I mean, if you look at Einstein, what was general relativity, he presented a 33-page essay, and it blew everybody's head, right? Because he had asked himself fundamentally the question, how does time space all fit together? I know you're a physicist, I shouldn't say this to you, but the point was, it wasn't all his idea. He had an amalgamation of those, but he distilled it down because he asked himself a question. Maybe there was some luck. I think that teaching people to ask themselves the question, how does this work? How am I going to do? I'll give you a question. I'm asking myself the question all the time. How do I disrupt existing businesses with AI? Right? Now, if you're a student, if you ask yourself that question, that's a great little side project to do that will develop your skills and use the technology out there to maybe try and answer those questions. So that's all I'm saying is it's that entrepreneurial thing. It's almost like, don't wait to be asked the question, ask yourself the question, how is this technology going to profoundly change what we do? That's my kind of chat with my son. It's because I think that the ideas will come from them, the young people who will see things that I can't see because I'm a bit old now.
Thank you. Back to you, Alex.
Yeah, that's really interesting. I think this idea of project-based learning is something that we're going to start seeing more and more in education, as people have access to all these tools and kind of in principle the ability to answer questions very easily. It's like how you use these tools in an intelligent way that I think will start kind of differentiating people in academia, but also in industry. But just kind of building on from that, so we've talked about democratizing the gaining of skills. Anybody become an engineer, anybody can pick up the kind of skills, the kind of code that they need to do a given job. But we also have from Andy earlier the need for kind of critical thinking during that approach. So I was wondering, Andy, is critical thinking something that exists independent from background domain knowledge, or is background domain knowledge always important? And just as an example of this, in academia now, people can write very good applications for certain kind of funding pots to do certain projects, telescope time, whatever. They don't have to be necessarily an expert in the domain to write a very convincing application, but then to kind of actually go forward and execute it, that's potentially a different thing. Now, I know those are kind of slightly two different questions, but yeah, where would you kind of come at this with a critical thinking question?
Yeah, so I think look, I think there's a sort of character and personality question here that I think some people are very good at it and some of them aren't. I think a lot of them tend to be probably an engineering brain of some sort. I think domain knowledge is a bit of a double-edged sword, because I actually think throughout my years of being involved in companies that were innovating, actually sometimes the left field thinking and the cross-fertilization from other markets is actually what you need, rather than actually having deep domain knowledge in a particular space and knowing the way it's always been done, and so on. So certainly, McLaren Applied, as we were building that business, actually that was what attracted blue chip companies to come and work with us, was to get that spark of outside thinking. Now I think there's two sides to that. So that's why I separate those two bullets on my slide. So one is the sort of human spark, if you like, which is, oh, I've seen this over here. Can we apply it over here? But then there's the critical thinking, which is about triaging those to say, well, actually, are they worth investigating or not? And then being able to direct the AI in terms of what it's doing and so on. So go back to your question. I think it's partly about personality trait. It's partly about willingness to cross-fertilize and not be obsessed with the domain. And actually, I think Ben made a really good point that everybody must in first glance think, oh, actually democratization of knowledge is a massively beneficial thing. So you talked about software engineers, Ben. Anybody can be a software engineer. It's similar in in picking up the skills needed to build a theoretical model of a particular thing. That actually one day you'll be able to just put an LLM at that, and actually you've got a good chance of getting a good result without being an expert yourself. But with that democratization becomes a massive risk, as Ben outlined, that you get unintended consequences. So I don't think anybody knows the answer to that yet, but I think we've just got to rely on the fact that people will continue to experiment, have a go, see how this stuff can be used. And I think we certainly here we are absolutely encouraging people to have a go at things and so on, but at the same time we've been really careful to put some rules of thumb around in place in terms of treatment of data, particularly client data and all of those things, so that we don't unwittingly take risks and so on. So I'd say, like any organization, we're trying to balance freeing the shackles of making progress, but at the same time not doing that blindly and making some nasty mistakes as a result.
Alex, could I just pick up on some of that,
Yep.
if you don't mind, very quickly? So that's the question that keeps me up at night. So I always think to myself, well, I'm clever, I think, without being arrogant about it, and I've spent a lot of my life being curious and sort of building my way up to the point where I can critically think about things and I understand the way around the subject. So the question is, if you don't go through that journey, yeah, and let's be real, I was an electrical engineer originally. I don't care about electronics anymore, right? They're in everything. I love electronics, by the way, but they're in everything. I don't care about them, right? Because I just care about what I'm running on top. So I shouldn't worry about the fact that I no longer need to understand how everything works down to the base level, although it's kind of nice to know how things generally work. So the question then is, in my experience of life, people who aren't necessarily engineers or academics tend to be really, really good at taking other people's ideas and making them to something that makes them very wealthy or very successful. What we need to do, I think, what would be really cool is if AI can be used with engineers to get them to be more business-led as well, right? Because believe me, engineers are super bright compared to the business people of the world. They really are, right? But they're not interested a lot of the time in the business world. So therefore, they focus on just the engineering side. If you look at all the great leaders of the great companies, they're all business engineers now. All of them. The US is just full of them. We need to do more of that in our country, and Ireland as well, UK and Ireland, and Europe for that matter. And I think that's where so I'm challenging is right to not just use AI to learn about the technical things of the world, use it to learn about how to run businesses and how to apply technology to create great businesses, right? Because ultimately we need the marriage of both, don't we? We don't just need the one, right? And that comes back to Professor Carsten's question about what I want from students. I want them to think about the application of it all as well.
I think that's an excellent point, Ben. I totally agree with you, because I always I'm an engineer, but I've been in commercial world for 20, 30 years, and I absolutely come at it from that angle. I think you're absolutely right. That's a good point. And just to point, actually, to echo your point about your son, at university. I've got a son at university doing engineering. And I was really interested that the first exposure he got to AI was having to critique the output of some AI as the core fundamental thing he was doing in a particular project. And so actually what was being taught there was, oh, well, this stuff's available, but you've got to apply critical thinking to it. And that's what they were starting off, doing, rather than introducing it to an AI tool or whatever, which I thought was interesting, sign of how things are moving.
That's great, thank you. So something I thought might be interesting to touch on. So we have Andy, who's based down in Cambridge. We have Carsten, who's been up in the Northwest for about 20 years now. And Ben, who's a recent Liverpudlian, kind of setting right up in the Liver building there. So we hear a lot about the Golden Triangle, kind of down in the south, Oxford, Cambridge, London. You have these big spaces for innovation, both in academia and in industry, and you have a lot of collaboration between the two. In the north, we're hearing that Manchester's doing quite a lot of good stuff, hoping that Liverpool can start to do the same. So first of all, Andy, I wonder if you could maybe kind of touch on what you think is going right around kind of Cambridge, around Oxford. How are the partnerships between these different sectors managed? Are they being done well? And then maybe kind of Ben and Carsten, you can kind of touch on what's so exciting about the Northwest and what kind of lessons we can learn.
Yeah, that's a really interesting question as well. So I think it's interesting because I think you always have to answer this question in the context of what AI is going to do to us to a degree. So I'm constantly frustrated in a way that some of the things that go on in Cambridge, and I'm sure in these other regions and so on, can lead to things being quite insular and parochial. So it can, promote some quite local sort of dialogue and people thinking that where they are is a center of the world and so on. Whereas, more than ever, businesses and tech is becoming global. So you have to take a global perspective. So I think there can be a bit of a double-edged sword there, that you can be a bit cocooned and so on. So I think it's really important to look outside. But then when I think you boil it down to what's the real value of those locations and so on, it's actually about the human to human interaction that it creates and the ease with which you can go and talk to somebody face to face. And obviously, social media, digital communication, all this stuff is kind of reducing, I think, the reliance on face-to-face communication. But when it comes to actually, achieving innovation and all the things that goes with it, actually face-to-face is really important. So I think probably one of the most fundamentally important things of these areas is that it promotes face-to-face contact between people who are like-minded and trying to do similar things. And that, if there was a single thing that you could achieve, that would be it. I mean, somebody once said to me that innovation is new value, not new things. And I think, that plays exactly to Ben's point about the fact that this is not just about the tech, it's about the commercial things. And all of those conversations and leaps that people make in terms of generating new value often happen face to face. So that, I think, is the value of those environments.
Yeah, that's really interesting. So it's that initial kind of critical mass of people who have similar, maybe not kind of directly aligned, but definitely complementary skills in the same place. Yeah, that's really interesting. Okay,
and then you get the talent attraction and everything that Ben was talking about as well. Obviously, that's really valuable. But I think it's the social aspect.
Fantastic. Okay, Ben. So, what could Liverpool be kind of doing better? What could the Northwest be doing better? I suppose you're kind of coming at this from an international company, and in the States, in particular, we have a lot of kind of strong interaction between academia and industry.
So sorry, Alex, I didn't quite understand the question. Do you mean as in what are we doing, Kyndryl, with academia, or more generally?
Yeah, kind of more generally, I suppose the kind of broader question is how can we make the Northwest as a region kind of more integrated between industry and academia? And what have you seen kind of across the different regions that Kyndryl works in?
I don't know the answer to the question yet, but I've got some early thoughts. What struck me is that there is a drive to create small businesses. I've met a lot of people in the Liverpool region who, especially combined with the combined local authority, Steve Rotherham, we spoke at the beginning of the session, the mayor, who are really ambitious, right? They really want to create small businesses and help them grow. and Kyndryl definitely want to be part of that. Yeah, and I think that we can potentially be a bit of a broker between the small businesses and the larger customers. I certainly bring in those ideas and trying to commercialize them more quickly. That's not steal them, that's commercialize them different, right? So we don't want, so that bit of an anti-pattern, I think, sometimes when you take small companies and do that with them. We want them to thrive and grow as well. So I think that's my definite early thing, early view on it. I think there's a lot of local companies, actually relatively large ones. We've got, I won't mention them on this call, but we've got big government organizations, banks, actually in the local region. We're very close to the Very Group, which is the retailer. We also have two other really large retail clients in the UK. So I think there's a real strong thing around retail itself that we can build out in the local region. And financial services and insurance. I think they're going to be our two main focuses with the smaller businesses. Just one thing I want to pick up on. I'm really sorry to change the subject back to what we were talking about, because it just struck me and I want to say it. I think that AI can help us become more polymath, right, people? Because if you think about it, the most amazing thing about universities like MIT in America is that they combine business with industry, which is kind of where your question is, Alex. I like it, yeah. But what often is the case there, that you need a biologist working with a physicist, working with a maths guy, working with a software engineer to answer the thing. So while AI might take people and let them become good software engineers, whereas before they would have struggled. For those people who are capable of learning lots and lots of things, I'm not trying to be elitist here, but there are people who can learn more things than other people. That's just a fact. Just like there are athletes who can run faster than other athletes. They're going to be able to learn more subjects and be broader, whether it's business and things, which that's got to be able to create more innovation as well. So I think, yeah, there's the business, locally there's the businesses we can help, but also individuals potentially can get support as well for their ideas. So I don't know, it's a bit of a rambling answer, but hopefully just a thought that you kind of made me think about while we were talking.
Yeah, I think it goes back to Andy's earlier points that innovation is less kind of new ideas and more kind of new applications of things that exist in different sectors.
Yeah, I've got a line as well with that, because I agree with that. I think also innovation is tomorrow's technical debt, right? So once we've built something, a lot of times people just leave it alone. It's added value and then do something else, and then it becomes technical debt. Anyway, sorry. So we've got two innovation quotes there.
Wonderful, thank you. Okay, I think we'll probably finish up with one question online from Milan, one of our postdocs at the University of Liverpool. So Milan asks, AI learns what it's been taught. Are there any strategies in your industries that regulate the kind of data that goes into training these models? For instance, do you have such things as training ethics?
Shall I go first? So we don't.
Yeah,
we are not in the business of training models, right? So, and there's a whole wider question: who should be in that business, right? We're not, taking lots of GPUs and creating models, but poisoning those models, whether it's deliberately or otherwise, I think the question is a brilliant question. So I'm afraid I don't have the answer, because the models aren't being created by. They've been created by, Google are creating them,
yeah.
NVIDIA are creating them with their technology. Even though they're a hard business, they're a software business as well. Amazon are, Azure are, Microsoft, they're all creating the LLMs. Maybe Andy is doing it. There's lots of local people doing it, but it costs an enormous amount of money, doesn't it? And that's why, DeepSeek's come about with its quant fund that's funded it, all of that sort of stuff. So we're not doing that, but I think there was, I think Grok is Elon's thing. I mean, clearly it's not poisoned so far, because you can ask it questions and it will give you answers that he would otherwise probably not like.
Yeah.
It's probably a matter of time though before those things are modified to filter. Certainly DeepSeek is, I think, if you ask some of the questions that they won't like. I won't touch on the subject because it's probably politically sensitive, but you know what I'm saying. So I think the answer to your question is we need to be involved in that, but at the moment a lot of those LLMs aren't being created by us. That's my view.
Andy, do you have anything you wanted to add to that?
Yeah, so I think, yeah, I mean, I think that the issue becomes when you're, well, there's two issues really. One big issue is when you're 2 steps removed from that process, as most of us are from an LLM perspective. So then there's a lot of, trust involved and so on, and those things are just so complicated, so much data involved. That's a really difficult task. Then I think there's a kind of first-hand question. So if you're building a model yourself, then how do you do that and so on? And I think, we don't build LLMs or large foundation models, but we, as I said, we do build models which are for specific tasks and specific products. And so I think, yes, modern AI makes that more, makes it easier and you do it in a slightly different way and so on. But that problem has already has always existed in machine learning and so on. So I guess, we just, in the same way as we take care about, the data that we use to base our decisions on and all of those things, we follow the same approach for clients. And I think over time, as those things get larger scale, I think more and more automation and tools will be needed for that. So I can definitely see that becoming more and more important. And that AIS bomb that I talked about, I think will actually, that at the moment is a kind of, it's a relatively small movement and so on, but I think actually that will become a thing. And I think, I've seen the UK government talking about model report cards and various things. I think that will become actually quite a big factor moving forward for sure.
Yeah, and I missed. You triggered me because I didn't. You're right. So the LLM in the foundation was we can't, but there's products out there. I mean, AWS have brought them out, Google brought them out. We can put guardrails around it, so we can we do post filtering. So that's the way that we'll help customers and businesses ensure that the data, I want to make a bomb, doesn't then give the results that you want as part of that. You can actually do post filtering on these LLMs. So that's how we'll help customers do it to make it. So we'll put the controls post LLM foundational model. And there's products out there to do that. I mean, what's interesting is the whole, if you've looked at the whole agentic AI, the agent versus agent discussion, we haven't even talked about that today. That's another level of discussion about AI. We talked about maybe the generative stuff that's helping us, but creating digital agents to actually do and automate processes, which is inevitable, and then agents talking to agents. There's a whole bunch of guardrails we need to put around that as well. So I think that's where I think a lot of the commerce will come from. Actually, is putting AI in a controlled way into businesses.
Wonderful, thank you. So we can have one last question from the audience. So I see Rabi has got their hand raised, so I'm just going to allow you to connect. Yeah, so Rabi, if you've got a question, feel free to unmute now and ask.
Hi, can you hear me?
Yeah.
Hi, so I've heard a lot, over the many years about, the tech side of AI, how we're developing that, looking at the programming languages, etc. So I did my PhD in 2011 on the effects of embodied conversational chatbots, avatars, etc., and how they affect humans, and how this AI tech will affect human behavior, perception, etc. But I see very little out there in terms of, for example, job roles related to that role. And I've contacted companies like Realbotics, Figure, and others about why don't you have roles that investigate how that, for example, humanoid is going to affect that human, because we're going to be spending a lot of money developing these bots, etc. And apparently there's going to be thousands going into people's homes. So why are we not looking at how humans will perceive these bots, behave towards these bots? Because a lot of my research has shown there's a lot of negative behavior can be elicited due to these bots. It could be, for example, various prejudices. They can be, humans can become very aggressive towards these bots, chatbots, etc. So there's very little discussion on that side, where we seem to just talk about the tech. That's great, but we also need to see how will that technology actually affect the humans? And if you're going to spend millions developing this humanoid, surely you should do some prototype testing, do some testing on humans. If you've got an aim and a goal, does it answer the research questions and goals you've set out? Because if it doesn't, then you need to go back to the drawing board. Because what could happen is you could have these humanoids going into every home, but then when you start getting negative feedback, when your, for example, bots get destroyed because there's an angry person in that house, just messed up your bot, where's that research? There's very little out there. And I was at academics, so I did produce a lot of work on that. But unfortunately, even at the university I was at, there was very little interest in investigating how humans perceive and behave towards these embodied, could be conversational chatbots and humanoids. So that's an area I'm really interested in, but I see very little discussion of that. And even in various organizations, there's very little discussion on that topic itself. But I think it's just as important as understanding the tech side, and how to develop that particular technology, etc.
Yeah, thanks, Robbie. Go ahead, Ben.
Sorry, I'd always jumping in. Sorry, so Robbie, I think you're ahead of your time. Simple as that, right? So we haven't seen the ramifications of what AI is going to do to us as a race, yeah. But to your point, I mean, you're talking one aspect of it. There could be many aspects of it, but I think that. So I think that's why you're probably struggling to get heard at the moment. But it will happen, and it will happen as we embrace it and adopt it, and time tells, and what those sort of social effects become apparent. So don't be disheartened that you've not been heard yet. You've done some valuable work there, and I think that it just is a matter of time before it becomes really relevant to the general populace.
Yeah, and I think if I could chime in as well, I think when we think about product development, we're always thinking about the human side of it and how the intended user is going to interact with it. So we do a lot of human factors work on the user experience, the user interface, all of those things. And we really want to understand that before we then move on to actually implement anything, because that is the most important thing that causes success or failure of a product in the kind of spaces that some of the spaces that we're in. So I think, Robbie, if you think about it as a kind of a stream within human factors, which is already a sort of well-established discipline, that might be a way of thinking about it. I think you might find, if you look in that direction, you might find that actually is beginning to be something that certain types of company will be interested in, and I think that will just grow over time.
Wonderful. Well, I think we'll close the panel discussion there. So thank you to Andy, Ben, and Carsten for a really fascinating discussion.